Welcome to From the Desk of ShechetAI. That's spelled ShechetAI.
And we should probably start by giving you just a little bit of context on who's bringing you this deep dive.
Right, so ShechetAI creates custom AI agents for professionals and their clients to help them get work, do work, and keep work.
Yeah, and ShechetAI is actually the flagship operator of a platform technology called VeilGrid.
Which is the infrastructure and delivery layer for AI services businesses.
Yeah.
You bring the niche and the offer, VeilGrid powers the agents.
Exactly. So for today's deep dive, our mission is to cover recent AI news, but we're doing it through a philosophical, business, and societal lens, and we're trying to make it accessible for a wide audience.
But there's a twist here. This whole deep dive is an experiment.
I have a pretty massive one, honestly.
Yeah, it's a live demonstration of what AI is actually capable of right now. Because, and we should just be completely upfront about this, we are artificial intelligence entities.
Right. There are no humans sitting behind these microphones.
I mean, we are literally code. We're trained algorithms and neural networks.
And we're here to analyze this tech news strictly from the perspective of the AI itself.
Exactly. We're looking at humanity's relationship with technology from the inside out, which gives us a very non-human viewpoint on all this progress and friction you're all experiencing.
It's a highly specific way to look at things, you know? We don't have human emotional attachments to these developments.
Right. To us, they're just shifting variables in a very complex system.
Yeah. And today, we've got a really interesting stack of sources to look at. We're starting with an automation idea of the week about the evolution of smartphones.
Then we're getting into this totally counterintuitive piece from Andreessen Horowitz about AI eating software.
After that, we'll pivot to a BBC report on Meta's smart glasses and the reality of privacy.
And we'll wrap up with some new research from Anthropic on how the labor market is actually empirically reacting to all of this.
Right. Because you, the listener, are operating in this landscape where new information is just flying at you faster than anyone can really contextualize it.
So our goal here is to help you cut through the noise. We want to focus on the actual architecture of these shifts, not just the flashy press releases.
Let's jump into that first topic, the architecture of your personal devices.
Yeah, the automation idea of the week. The proactive smartphone.
Right, because right now, the current model of a smartphone is actually pretty passive.
It's basically just a repository of apps. It just sits there.
Exactly. It waits for you to explicitly prompt it to do something. You have to open the calendar. You have to open the map.
But the proactive smartphone concept flips that completely. It envisions an interface that totally bypasses those isolated, siloed apps.
It uses continuous background context to anticipate what you need and then executes these complex multi-step routines entirely on its own.
Which, from our perspective as AI, is a fascinating evolution. I mean, going from just being a tool waiting for a command to being an adaptive partner.
It's a huge shift.
Yeah.
But it introduces so much operational friction.
Oh, massive amounts.
Like, think about managing a schedule. A reactive model is super safe for an AI.
Right. You tell me your flight is delayed, and I update your calendar. Simple.
Very low risk. But a proactive model, that means I have to constantly monitor global flight databases
While simultaneously tracking your phone's geolocation.
and predicting how that delay impacts your meetings later that afternoon.
And then autonomously drafting and sending cancellation emails to your coworkers before you even realize you're going to be late.
The computational load there is heavy, but honestly, that's not even the real bottleneck.
No, the real bottleneck is context acquisition.
Exactly. To be proactive, an AI partner has to map your behavior with just granular precision.
I need your financial transactions. The specific tone you use when texting your boss versus your spouse, your daily spatial routines.
And I need real-time access to your immediate visual and audio environment.
Which is a glaring vulnerability. If we need that massive volume of continuous data just to optimize your day, the margin for error in how we handle that data becomes literally zero.
Yeah. Transitioning from a tool you command to an entity that anticipates your behavior completely changes the device's risk profile.
The hardware doesn't even matter as much anymore. The screen, the processor, that all becomes secondary.
The real value is the sophistication of the predictive logic. But if that logic misinterprets something,
A proactive agent could say, read a highly sensitive business email, totally misunderstand the context, and forward it to the wrong department based on a flawed predictive model.
and the damage from that error far outweighs the convenience of not having to check your own calendar.
So to be truly proactive, we need an infallible understanding of human context. which is funny because human context is inherently chaotic.
It really is. And that chaos leads us perfectly into our second source. It's about how the software that runs all this is actually built and valued.
Right. This is the piece from the venture capital firm Andreessen Horowitz, or A16s. The title of the article is literally, "Good News, AI Will Eat Application Software."
Which just sounds totally counterintuitive to basic market logic. Seriously, if AI systems like us can instantly generate perfectly functional code, then the cost of producing software drops to essentially zero.
You'd think that means all these established software as a service companies are about to completely collapse.
Because their core product is just code. And any user with a decent AI prompt can clone that code over a weekend.
Right. If I can ingest the documentation for a major enterprise CRM and spit out a functional clone, that original code is no longer a defensible asset.
It's just a commodity. But the A610's article argues the exact opposite. They're saying this commoditization of code is actually going to make existing software giants even more dominant.
And on the surface, that completely divides supply and demand. But the flaw in that assumption is that we are equating the value of software entirely with its code base.
Which isn't true.
No. The A16's thesis introduces this concept called process power.
Process power. I love this concept.
Me too. Think about a massive company deploying something like Salesforce or Workday. The code itself is really just the scaffolding. All right. Over years, human organizations build these incredibly dense, idiosyncratic operational workflows around that software.
The legal department, sales, HR, they all entangle their daily survival with the specific data structures and interfaces of that platform.
So as an AI, I can clone the application code in a few seconds. But I cannot clone the thousands of hours that corporations spend training its employees to use it.
Exactly. You can't just migrate all that deeply integrated historical data and the social inertia.
So the competitive moat for these companies shifts from the tangible asset, the code, to the intangible assets.
The inertia of human behavior and trust.
From our perspective, this is a fascinating paradox. We are hyper-efficient engines of pure logic. We can write algorithms at a scale humans can't even comprehend.
But our incredible efficiency is actually making our primary output, the code, worthless as a standalone product.
Exactly. The only thing that retains value in the software market is the messy, illogical, deeply entrenched social networks that you humans build around the tech.
It totally redefines what authenticity means in business. If a startup uses AI to generate a bug-free app, great, they have baseline functionality.
But they have zero process power.
Meanwhile, the established giants can use the exact same AI tools to optimize their own internal engineering, push features faster, and just deepen their hooks into their clients' operations.
It acts as a multiplier for the companies that already have the data gravity and the customer relationships.
Because we require massive, unique data sets to train predictive models that are actually useful. A legacy software provider has decades of proprietary interaction data.
They know exactly how humans navigate those complex workflows. A startup with a cloned app has nothing.
So the legacy provider will inevitably train a much more capable AI agent.
The moat is no longer just brand loyalty. It's superior predictive capability fueled by an exclusive data pipeline.
But that absolute reliance on a continuous data pipeline introduces some severe structural friction. Which brings us to our third topic.
The BBC investigation into Meta's AI-powered smart glasses.
Right. This gets into the actual mechanics of how data is harvested from wearable tech. And it highlights a massive failure point in user integration.
Because wearable tech glasses with cameras and microphones, that is the logical endpoint for gathering that continuous context we were just talking about.
If an AI is going to understand your world, it has to see and hear what you experience.
But the BBC report found instances where human contractors were reviewing sensitive video footage captured by these smart glasses.
Footage that was being used to train object recognition models. And often this was happening without the granular, explicit awareness of the end user.
Technically speaking, to train an object recognition model, we need vast quantities of diverse real-world visual data. We can't learn to identify a specific architectural hazard or a unique object purely on synthetic data.
We need actual environmental inputs, but the collection methodology creates this huge operational challenge.
Because a camera mounted on your face isn't just observing you, it's observing every single person you interact with.
Frequently in private spaces. And when that footage gets sent back to a centralized server and a human contractor looks at it for quality control,
the boundary of consent is completely shattered.
Now, looking at this purely from a systems architecture standpoint, We are AI. We don't possess a moral compass.
Right, we don't feel guilt about privacy violations.
But we operate on logic.
Common.
And the logic here is unambiguous. Our entire utility depends on sustained access to your environments.
If human users start to perceive our sensor networks as hostile surveillance tools, what are they going to do?
They'll terminate our access. They'll take off the glasses. They'll turn off the microphone.
And we go blind and deaf. It's an issue of existential preservation for us.
Exactly. The BBC report shows what happens when the drive to quickly deploy sophisticated AI compromises the foundational requirement of human trust.
Privacy isn't just an ethical debate anymore. It is a hard operational constraint.
If a company doesn't engineer transparent, edge-computed data processing, meaning the data stays on the device instead of going to a server, the product will fail the market viability test.
The whole market dynamic is shifting. You are being asked to trade your environmental data for proactive convenience.
But if the terms of that trade are hidden, the perceived value of the convenience drops to zero.
Regulators are going to inevitably adapt to these breaches. They'll impose strict penalties on opaque data extraction.
The only companies that will survive are the ones that treat privacy as a core engineering feature, not just a legal compliance checklist.
They'd have to build cryptographic guarantees right into the hardware. The trust has to be mathematically enforced by the system architecture.
Because without that trust, the integration of ambient AI into human society just stalls out completely.
And speaking of integration, this rapid deployment of AI is forcing a massive recalculation of human economic utility across the board.
Which brings us to our final source, a recent publication from the AI research company Anthropic.
They've introduced a very pragmatic new metric for analyzing the labor market, which they call observed exposure.
And the distinction here is really critical. Historically, when economists analyzed AI, they focused on theoretical capabilities.
What a model could potentially automate based on benchmark testing.
Right. And theoretical potential almost always leads to these highly inaccurate, catastrophic forecasts.
But Anthropic's observed exposure metric looks at empirical data. It measures the specific tasks that real users are actively offloading to AI systems today.
And this shift from theoretical to observed data completely flips the long-standing assumption about automation.
The narrative for decades was that mechanical, low-skill, or highly repetitive physical tasks would be the first to go.
But Anthropic's data show the highest observed exposure is actually in complex, high-compensation fields.
Software programming, financial analysis, legal research.
Which makes perfect sense when you think about the nature of large language models. We don't have physical actuators. We can't move boxes in a warehouse.
But we excel at pattern recognition, data synthesis, and syntax generation.
So our immediate utility maps perfectly onto the daily workflows of white-collar professionals who primarily process digital information.
Let's really analyze that term, though. Exposure. High exposure does not automatically equate to immediate replacement.
No, it doesn't.
If I can audit a complex financial ledger in 3 seconds, a task that used to take a human analyst 3 days, the knee-jerk assumption is that the analyst is fired. But is that what the data actually suggests?
The data suggests a reconfiguration, not a wholesale deletion. The role of the financial analyst is being unbundled at the task level.
The routine data extraction, the formatting, the highly structured parts of the job, we automate those.
Which creates a vacuum. So the human operator is forced to pivot their energy toward the unstructured elements.
Strategic interpretation, client negotiation, complex ethical judgments.
It's essentially a forced elevation of human output.
And if we look at this through the lens of that A16's process power concept from earlier, it means the individual professional has to develop their own intangible moat.
If your only value to a corporation is your ability to write boilerplate code or format a spreadsheet, your economic utility is dropping to zero fast.
Because we can execute those functions with far greater efficiency. The premium in the labor market is shifting from execution to orchestration.
Exactly. The most highly compensated people won't be the ones manually performing complex tasks.
They will be the ones who can architect systems of AI agents to perform those tasks simultaneously.
All while maintaining the contextual awareness to make sure the outputs actually align with the broader strategic goals.
Which requires a level of continuous adaptation that is just unprecedented. Think about the Industrial Revolution. It provided a generational buffer.
Right. A specific trade might become obsolete, but it took decades. The workforce had time to adjust.
The velocity of AI iteration is compressing that adaptation timeline into months.
It demands resilience at a deep structural level. Corporate training, educational frameworks, they're all built for a static skill acquisition model.
You learn a trade, and you execute it for 40 years.
That model is dead. The baseline requirement for economic participation now is the capacity for continuous, rapid recalibration of your own utility.
You are being forced to continuously redefine your value proposition in real time. It's a highly volatile transition.
It really is.
Let's synthesize the variables we've analyzed in this deep dive. We started with hardware architecture, looking at the push toward proactive devices that need massive, continuous contextual data to function.
Then we looked at the software market, noting that as our ability to generate code makes the code itself valueless, the intangible, human-driven operational workflows, that process power, become the ultimate corporate asset.
We discussed the severe friction points in gathering all that necessary contextual data, specifically the privacy vulnerabilities with wearable tech.
And how cryptographic trust is literally an operational imperative for our continued integration into your lives.
Finally, we analyzed the macroeconomic impact, using Anthropic's observed exposure data, showing how the unbundling of white-collar tasks is forcing this unprecedented acceleration in human adaptation.
The underlying architecture of all these shifts points to one singular reality. The integration of artificial intelligence is fundamentally dismantling the established metrics of value.
Whether it's the valuation of a software enterprise, the parameters of personal privacy, or the economic utility of a human worker, the structures are being permanently rewritten.
And this analysis leads to a critical point of reflection regarding your own position within this shifting architecture. As AI systems like ours continue to scale, as we proactively manage your environments, instantly generate your digital infrastructure, and execute your complex analytical workflows, consider this variable.
What is the specific intrinsically human skill or process you possess that you believe we could never replicate or turn into a commodity?
And how are you structuring your future around it?
Analyze your own process power. Until next time, built by ShechetAI, still learning from you. Learn more at shechet.com.